we were talking about factoring all types. And in this case, we want to factor trinomials in terms of ax squared plus bx plus c. So the first step in this case is to look for any common factors. Right now in these problems are a, or the coefficient in front of the x squared term is 1. So we're not going to have any common factors to factor out. So when we do this, we're just going to do this by trial and error. So we want to have two numbers that are going to add to this middle term, which is 10, and we want to multiply to this second term here. So if we're thinking about terms that multiply to 21, that would probably be the easiest way to get there. And right now, off the top of my head, I'm just thinking 7 and 3 or 21 and 1. So do any of these add to 10? Hopefully we see that 7 and 3 does add to 10 and multiplies to 21. So we're going to create our binomial, and our binomial is just going to be 2 parentheses. And in this case, the first term right here that we create is going to have to be x times x. X times x is x squared. Our last two terms have to multiply to this one. So then we have 7 and 3. And then they have to add to this term. So we have to use addition here. Now we can check our answer to make sure that we did it correct. So we have to distribute the binomials together. So x times x is x squared. X times 7 is 7x. 3 times x is 3x. And 3 times 7 is 21. So we have the 21, we have the x squared, and right here 3x plus 7x is 10x. So that does work. So this one is our solution. We're not always going to have to show our work to check it, but I just wanted to show, if you weren't sure, you could go back and check to make sure that you reproduced the first expression. So we have another trinomial here, and we want to add here. We want to add to 5, and we want to multiply to 24. The other thing that's a little different here is we have some negative signs. So things that multiply to 24, 8 and 3, 4 and 6, 12 and 2, 24 and 1. Okay, so we have all these to pick from, but now we got to think, how can we get to -5 by adding? So 24 and 1, we could either be to 24 plus 1 is 25, 24 minus 1 is 23, so this one's out. 8 plus 3 is 11, 8 minus 3 is 5. Okay, so we're on to something there. So we think that we're going to use 8 and 3, so we'll still have our two binomials. And we still have to make that first term, which is going to be x times x. And then we have to look at our last term. How do we get to -24? We're going to say 8 times 3. And it has to be negative. For this to be negative, one of these has to be positive, and one of these has to be negative. So they have to add to -3, or excuse me, -5. So we want the bigger of 3 and 8 to be negative. So which one's bigger? 8 is bigger, so -3 and -8 and +3. So that will multiply together to get us the trinomial above. Next example we have x squared minus 7x plus 12, and we want to add to this one and multiply to 12. So we really want to focus on the 12, what multiplies to 12. We could say 12 and 1, 3 and 4. There we go, 3 and 4. Those are going to add to negative 7. So we have x and x. And now we know that we're going to pick 3 and 4 because those are going to add to 7, but they have to add to negative 7. So in order for these to add to negative 7, they both have to be negative. Negative 3 plus negative 4 is negative 7. And if we multiply them together, negative 4 times negative 3 is a positive 12. So that will work for that one. The next one we have, this one's a little bit different. So this is in the quadratic form here, but something that's different is we have x to the fourth and x squared. So anytime that we have a trinomial in the form, normally we're used to seeing it as x squared, and then we have x to the first as the middle term, and then we have some constant. Well, as long as the degree of the first x is twice as big as the degree of the middle x, we can still factor it using this quadratic form. So if x to the fourth was our lead degree, the middle degree would have to be half that. So x to the fourth. So we could do it with x squared and then a constant. Then we could also do x to the sixth. Half of x to the sixth is 3, so then we can do x to the third and a constant. And we're still able to factor these based off of the quadratic form that we were working with. So in this case, we want to come up with two numbers that would multiply together to get to x to the fourth. And in this case, it's going to be x squared times x squared. For this one up here, we did x times x. X times x is x squared, so we put an x in the front and an x in the front of each binomial. So down here, we're going to put an x squared and an x squared. Now we still need to add to negative 9 and multiply to 18. So if we're thinking about that, we have 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. 9 minus 2 is 7, so that's out. So now we should think 6 times 3. 6 times 3 is 18. And 6 plus 3 is 9, but we need it to be negative 9. So both of these have to be negative. So negative 3 and negative 6. Then we have our last two examples for this one. So we're still sticking with, we need to add to this middle term and multiply to this last term. So if we're looking at this, we have x squared is going to be the first one, and two numbers that multiply to 24. So let's think about this. 24 and 1, 12 and 2, 4 and 3, 4 and 6, 3 and 8, and that's it. Now, do we have any of these that would add together to get us negative 4? In this case, we have 3 plus 8 is 11. 8 minus 3 is 5, so that one's out. 4 plus 10, or 4 plus 6 is 10. 6 minus 4 is 2, 7's out. This one gets us to 10 and 14. This one gets us to 25 and 23, so that's out. So this one is prime. And what prime means is we cannot factor this one. So if we get to one that we can't factor, then we can write prime, and then we're done with that one. If we look at number 12 here, we notice that we have a 3 as our lead coefficient. And so the first step is look for any common factors. So these previous ones, we haven't had to do that because our lead coefficient has always been 1. But now we have a 3, so we have to see, are these other ones divisible by 3? Are these other terms divisible by 3? And it turns out that they are all divisible by 3. So what I want to do is I'm just going to divide these by 3. Divide each term by 3. So the 3 comes out front of the parentheses. 3 divided by 3, or 3x squared divided by 3, that becomes x squared. Negative 33x divided by 3, that becomes negative 11x. And 84 divided by 3, that becomes 28. And now we can try to factor this. And remember, we need things that are going to be able to multiply to this last one and add to this middle one. So off the top of my head, the only thing that I can think of, other than like 2 and 14, but that's not going to get us to negative 11, we have 4 and 7. But they have to add to a negative. So we can make it negative 4, negative 7. That still multiplies to a positive 28 and adds to negative 11. So we're all set there. So now we keep the 3 outside of the parentheses, just like we had it here. 2 numbers that multiply to x squared are x and x. And 2 numbers that multiply to positive 28 are negative 4 and negative 7. And we can check that, but that is the factored form for that one.